Please get out your note sheet for 6-1 solving systems by graphing.
All right, so this isn't on your note sheet, but we're going to just take a look at what a systems of equations would look like as a graph. So here you're comparing River Paddlers to Boat Express, which is just two different boating companies, and the cost that it is to rent a boat for a certain number of hours. So you can see by the lines that they're not the same cost, that one of them, starts at 0 and you just pay per hour. And then the other company, River Paddlers, actually makes you pay just to rent the boat, but then you pay a different cost for each hour, so that's why it's two different lines. Now, a solution to a systems of equations would be the one point where both of these boats would cost the same after a certain number of hours. So what you would ultimately be looking for is where these two share a same point, and that would be at 4 hours. They both are $20. So a solution to a system is where both of the lines would have the same ordered pair. It only happens once in this kind of problem. In most problems it only happens once, and so you're basically thinking of where they would intersect from a graph's point. Here's another one where we're comparing video rentals to the cost, and the solution would be after how many videos would they cost the same, and you see that point is already emphasized, and that would look like it would be five videos, and the cost would be between 12 and 13, which would be $12.50. Here's another one comparing money saved by Dan and Lisa. It looks like Lisa's saving a little more per week than Dan is. Dan's saving less, but he has more at the beginning. So what we would look for as a solution is when do they have the same amount of money after how many weeks, so where they cross, which would be 5 weeks and $300. All right, so your official definition of a system of equations is a solution or the ordered pair that makes the two equations true. So for the last examples, it was the spot where we saw them intersect, and why that's the solution is because if it's part of one line and part of another line, and they happen to cross at that one specific ordered pair, then that's the only spot where they share the same ordered pair, which makes it the solution to both of those equations. So here's a quick example of two equations, and you might be able to look at this one and tell, but basically there is an ordered pair that makes both of these equations true, and so you're saying you have the same x value and the same y value that can get plugged into both of these and make a true statement. And so if you want to try and see if you can figure those out really quick, and then if not, we'll take a look at this in a second, but when you see it on a graph, you just see the ordered pair. If you're doing it from an equation, we'll look at that a little bit later. So if I kind of just start picking some numbers for x and y to figure out what's going to work, I obviously know for the first equation that 3 plus 3 is how I'm going to get 6, which means the y value would be 1, and then that's going to give me a 3, and then I would want x to be 3. And the second one, then it should work if I plug in 3 for x and subtract 2 times 1, then I'm going to get 1, and that works. Not all of them are this easy, but that's just kind of a general look at how systems work. It's an ordered pair that makes both equations true. When it's graphed, it's where they intersect. When it's not graphed, it's ones that can be plugged in to make them both true. Okay, so on your kinds of solutions, there's going to be 3 different kinds for a system. First one we're going to look at is one solution, and that's what we've already seen. And one solution is when the graphs cross at only one point. So you've got 2 straight lines, they're basically slanted at different amounts, and they're going to cross exactly one time. Now, how can you tell that this is going to happen? It will happen every time you have 2 equations that have different slopes. Different slopes mean the steepness is different, and if you have different steepnesses, then at some point both of those lines will cross each other exactly once. And an example of that, since we're going to talk about slopes, here's 2 equations, solve for y, so in slope-intercept form, and there's 2 completely different slopes here, a slope of 1/2 versus a slope of -2/3. Doesn't have to just be this example. Any 2 slopes that are completely different will always cross one time. Second kind of solution would be no solution, and no solution basically means that the graphs are parallel, and if they're parallel they will never cross, so you might want to actually also add that the lines never intersect. Because if they never intersect each other, then they're never going to share a common point, which would be a solution for us. So parallel lines never cross each other would mean no solutions. How you can tell from an equation is if both equations have the same slope. So if you want to be lazy when you're doing yours, you can just say same m, but different y-intercept, so different b. which means they're going to rise and run at the same rate, so it's the same exact slope, up 2/3, but they're starting at different spots, so they're never going to cross each other if they're constantly going the same rate, but beginning in different positions. So, example of this, any two equations that have exactly the same slope but a different y-intercept. So here's an example you can write on your note sheet. If you had to envision what that would look like, and I'm just going to do a very generic, here starting at -3 with a slope of 2 would look something like that. Here starting at +1 with a slope of 2, and it would look something like that. So those are never going to cross each other. Okay, and then the last kind of solution is infinite many solutions, and this is when the graphs are the same, and so they're always going to cross each other. So if you have two equations that are exactly the same and you graph them, that's literally going to be one line on top of the other line, which means how many times do they cross or where do they cross? Well, they cross everywhere if they're exactly the same line. So how can we tell? Well, both the equations have the same slope and same y-intercept. That makes it the same equation. And then an example could be something like y equals x plus 2 and y equals x plus 2. If I go to graph them, and I do graph both, they're just both the same line. So the bottom one will cross over the other one every single point, and that makes it infinite many solutions, so same exact lines. Okay, here's your steps for solving systems by graphing. Step 1 would be to solve each equation for y. If we're going to graph, we need slope-intercept form. Step 2, graph each equation. And then step 3, find the point where they intersect and label your point. If they never do, you would say no solutions. If it's the same line, you would say infinite many. So we're going to take a look at some of these examples so you can get practice with graphing. So your first one here, we're going to go ahead and graph, but we're going to solve for y. So we're going to divide both sides by -2, and we're going to get y equals 2x plus 3. Our second equation, we're going to divide by that -1, and we're going to get y equals 2x plus 3. So if you're already kind of realizing what's going on here, if I go to graph at +3, my slope of 2, it's going to look something like this. And if I wanted to spend all day drawing those points, I could, but I'm just going to do a few. And then I'm going to switch colors. It's really good to color code, actually, when you do systems by graphing. My blue line, so I'm going to start at 3, have my slope of 2, and you can kind of see what's happening. It shares every single point. So again, if I was more perfected with these lines, it's exactly the same lines. So the way you would answer this would be infinite many solutions for this kind of problem. And you've got exactly the same lines graphed there. Okay, second one, so again, I'm going to solve the top for x in red. So I'm going to subtract x, which gives me -x minus 3. So I can graph this line. I've got that negative slope starting at -3. And then my second equation, I'm going to subtract x, which gives me -x plus 3. Now be careful, these aren't exactly the same. This time I have a y-intercept at +3 with this -1 slope. So when I connect this line, it's going to look like that. So we have the same slope, different y-intercepts. My answer to this kind of problem would end up being no solutions, and you can see that those lines are parallel. They're never going to cross each other since they have the same slope. Okay, and then third example, we're going to go ahead and solve for y. So I'm going to subtract 2x first. That's going to give me a -2x minus 3. But then I've got that -y, so I'm going to divide by a negative, which will change these into positives. So I can graph starting at 3. I've got this +2 slope. I'm going to connect, get something like that. And then my second line, I'm going to do in blue. So I'm going to subtract subtract 3x, which will make it a -3x, and divide by the negative, which is going to end up changing these signs. And now I've got 3x minus 1. So from -1, I rise 3, run 1, rise 3, run 1, rise 3, run 1, rise 3, run 1. And if I connect my blue points, I should find that I actually have this spot right up here where these two lines cross. So because these have two different slopes, this answer would be one solution, and that solution is where those two cross, which was right up here, and that ordered pair would be 4, 11, which means if you plug in 4 for x, you should get 11 for both of these equations. That's the only time they share an ordered pair. So you can pause the video and try number 4 and then press play whenever you're ready to check. So you should have had y equals 2x for your top equation, and then y equals 3x minus 1. They have different slopes, so they should cross once, and they should cross at 1, 2. Okay, go ahead and pause and try number 5, and then press play when you're ready to check. Okay, so number 5, you should end up with that one solution, and the nice thing about this one is that maybe you realized that the solution was the y-intercept. If you have different slopes but the same y-intercept, then that y-intercept is your solution, which would be at 0, -1. And last one, number 6, go ahead and pause and try it, and then press play when you're ready to check. So example 6 should end up being infinite many solutions, and when you solve the bottom equation for y, you end up getting the same equation as the top. So if you graph these, they are the same lines, just right on top of each other, so that means they share ordered pairs the entire line, so infinite many. So that's it. There's some IXL for you guys to practice some more of this, and then we will take a look at some other methods as we go on through this unit. See ya.